Por favor, muchas gracias. Muchas gracias por el interés que ha despertado esta conferencia. Me congratulo como profesor de la universidad la asistencia que vamos a tener esta tarde en la conferencia que se pronuncia dentro del ciclo dedicado a Nicolas Tesla. Y sí os pediría, por favor, que las cosas que tuvierais colocadas en algunos asientos las quitarais para dejar libre los asientos, que se vean claros los asientos que tenemos, porque desgraciadamente en este caso hemos tenido una asistencia mayor de la esperada y el salón de actos se nos ha quedado pequeño. Por un lado, es de felicitarse por este éxito, pero por otro lado lamento mucho que las personas que se han quedado fuera no puedan asistir a esta conferencia. De modo que en la medida que podamos aprovechar y apurar al máximo los asientos, os rogaría que dejarais libres, no pusierais ninguna cosa, para que pudieran entrar algunos compañeros más o personas ajenas a la universidad que también han mostrado su interés en asistir a esta conferencia de hoy. Bien, la conferencia de hoy es la segunda conferencia del ciclo dedicado a Nicolas Tesla, que viene acompañado, este ciclo, de la exposición que se encuentra expuesta en el vestíbulo, en la entrada de la escuela, en la denominada Sala de la Máquina. Rogaría, por favor, que dado que somos tantos y tenemos además una conferencia interesante por delante, os rogaría, por favor, que mantuvierais el mayor de los silencios, porque en estas ocasiones cualquier ruido se multiplica mucho más. Bien, quiero empezar, por lo tanto, agradeciéndoos a todos el interés que os habéis tomado, agradecer a la Escuela todo el esfuerzo que está haciendo con esta exposición, un esfuerzo mayúsculo que están llevando directamente los miembros de la dirección de la Escuela, por la organización de la exposición y también por la coordinación y organización del ciclo de conferencias, que si bien en algún caso, como el que nos trajo aquí a esta misma sala no hace mucho, pues no conllevó ninguna dificultad organizativa, en esta ocasión se han tenido que hacer un esfuerzo organizativo adicional, así que quiero reconocer todo el esfuerzo que están haciendo y han hecho especialmente hoy los miembros de la dirección de esta escuela. Bien, dicho esto, vamos a pasar directamente a la conferencia que hoy nos va a impartir el profesor Carlson y lo vamos naturalmente a hacer en inglés, como estaba previsto. Quizá la mayoría tenéis los cascos necesarios para el sistema de traducción simultánea, otros quizá no lo necesitéis porque podáis seguir la conferencia en inglés sin problemas. Y en todo caso, pues siempre, nunca será suficientes veces las que os digamos que en una universidad técnica como la nuestra, pues lógicamente el inglés tiene que formar parte de vuestra formación diaria continuamente. Entonces, conferencias como la de hoy también buscan sensibilizaros y daros a ver la importancia que tiene el idioma inglés en un mundo técnico como el que nos rodea dentro de las enseñanzas que impartimos en la Universidad Politécnica de Madrid. Así que voy a conmutar ya a inglés para presentar a nuestro conferenciante. I'm going to switch to English to introduce you. Carlson is a professor at the University of Virginia with appointments in the Department of Science, Technology and Society and the History Department of this university. He received his PhD degree in the history of sociology of science from the University of Pennsylvania, and did his postdoctoral work in business history at the Harvard Business School. He has held visiting appointments at Stanford University and the University of Manchester. Professor Carlson is an expert on the role of technology and innovation in American history, and his research focuses on how inventors, engineers, and managers used technology in the development of major firms between the American Civil War and World War I. His publications include titles such as Innovation as a Social Process, Elihu Thomson and the Rise of General Electric, as well as the book titled Technology in World History. This book was awarded the Hacker Prize by the Society for the History of Technology this year precisely for being the best popular book in the field. With support from the Sloan Foundation, he is currently completing a biography on Nikola Tesla. Professor Carlson will give us the second address in the series of conferences organized with the occasion of the exhibition on Nikola Tesla titled The Man Who Lit Up the World, shown at the main lobby of this school. In his speech, Professor Carlson will compare Tesla's experience with inventing the motor to his efforts to introduce his system of wireless light and power. In doing so, he will emphasize how his relationship with people, particularly his business partners, informed how the technology was developed. Professor Carlson, thank you very much to have accepted our invitation to give this talk about Tesla, and it's our privilege to have you with us today to talk about Tesla in New York in his most exciting years or golden years of Tesla that runs from 1884 to 1904. So thank you, Professor Carlson, the floor is yours.
Thank you very much. Before I start, let me say a word of gratitude and thanks to my hosts from your university, Professor Antonio Ust, who just introduced me, and also to the representative from the Embassy of Croatia, Nikolina Zedic. And thanks to the government of Croatia for helping bring this lovely exhibit that you have in the lobby of your university. I also want to say thank you to all of you for coming tonight. I teach in an engineering school, and normally I give so much homework that nobody has time to come out to a lecture like this, so thank you for coming out. I have to say that I've lectured on Tesla, I've worked on Tesla for a number of years, almost 10 years. I've given talks in a couple of different countries, in France and Germany. This is my first time in Spain, and I am very pleased and gratified that you are the largest audience that I've had the privilege to talk about Tesla with tonight. Now, for your entertainment and your education, you know, as a professor, I often say that I entertain first, I engage second, and then finally I educate. So I will try to be a little bit of entertaining to get your attention and to get you excited about Nikola Tesla and his important contributions to engineering and to the world that we live in. Now, as a historian, you often, you can often think that historians go around and they spend a lot of time doing very boring things. But historians are also a bit like novelists or movie makers in that they look for the portion of a historical figure's life where there is, as we would say in America, the most juice, the most energy. And the period that I want us to talk about tonight is from 1884 to 1904 because it is the period that is very dynamic, very lively, and has a great deal of ups and downs for Tesla. And as you'll see, the pattern is from rags to riches to frustration. In 1884, Tesla arrives in the United States, in New York City, as an immigrant. He's one of millions of Europeans who comes to America between the 1880s and 1910. But Tesla, like everyone else, arrives with only a few cents in his pocket. But remarkably, In 10 short years, he is the toast of the town. He is at the height of his powers. Along with Thomas Edison, Tesla is regarded as one of the two great electrical wizards. If you were to open up the newspapers of that time period and look, they would always be talking about Edison and Tesla in the same sentence, in the same voice. They were both regarded as the wizards, as the highly creative engineers that were changing the world right underneath people's feet. So 1884 he arrives. 1894 he's at the peak of his powers. But in 1904 Tesla has been eclipsed by Marconi in the area of radio. So how is it that Tesla had this fabulous rise and he was at the peak of his powers and then he has this fall? How can we make sense of the twists and turns of his career? Why did these things happen? What were his strengths and weaknesses? What can we learn from him as a person, as a creative individual? So, I know what I'm going to do. Okay, so let me tell you a little bit about Tesla's early life because I want to focus primarily on his time in New York. As Professor Ust said, I want to talk about his motor and I want to talk about his work on wireless power and compare the two for you. So just a little bit on his background life. Tesla was born in 1856 to a Serbian family who was living in what is today modern-day Croatia. At that time, it was the military frontier of the Austro-Hungarian border, or Austro-Hungarian Empire. As a young man, he went to study at the engineering school in Graz, Austria, the Johanna Polytechnic School, which was very much in the Grande École tradition of engineering schools at that time. It was founded in about 1820, and it is very similar in its style to what your university was when it first started in the 19th century. Tesla, and I probably shouldn't tell students this, he only spent 3 years at the university. He thought he was going to be a mathematician. He then changed to engineering. He studied for 3 years. He did very well, but suddenly he came into some money, and he dropped out of school. Now, don't you drop out of school. Okay, but he went on a number of years of travel and visiting various cities in Eastern and Central Europe. He went for a time to Prague. He went to a number of other cities, and he traveled. And again, I shouldn't tell you this. He drank. You would never drink, right? He drank beer. He drank wine. He gambled. He was an outstanding billiard player. But in 1882, he wound up in Budapest. Through some family connections, he went to work for building the first Edison telephone exchange in Budapest and helped get that up and running. As a result of that, he was invited to come and work for the Edison companies that were installing electric lighting plants in Paris. And finally, in 1884, he emigrated to New York with a letter in his pocket that legendary says, the letter says to Edison, you know, I know two great men in the world. One of them is you, and the other one is this young man. So, pretty good letter of recommendation. See if your professor will write one like that for you. For the next 2 years, Edison worked for the Edison Company. He worked at the Edison Machine Works, which is a large factory located in Lower Manhattan. There he helped design electric generators and electric motors. These were all direct current motors. Edison wasn't interested in alternating current, as you undoubtedly know. And Tesla was put to work developing what was an arc lighting system. Now, arc lights are very big street lights that you would put out tens of thousands of candle power and would be used for applications like lighting department stores or amusement parks or that sort of thing. Very different than the little incandescent lights that we know so well and we associate with Edison. Edison decided not to build or manufacture the arc lighting system, and Tesla, in disgust, quit. Tesla was very good at quitting companies, as you'll see, and he went to work for a team of businessmen from Rahway, New Jersey, which is a small industrial town in central New Jersey, about 30 miles from New York City. And the Rahway backers liked Tesla, and they liked his patents, and they liked his arc lighting system, and they installed it in their city, and as soon as they installed it in their city, they fired him. And so he was out of work again and was forced to dig ditches and to struggle for several years. Now, probably Tesla's best or biggest piece of good luck was in 1886, he by chance, and I still don't know which man he met first, but he met two men, Alfred Brown, who worked for the Western Union Telegraph Company, then the largest telegraph company in the United States, and he also met a man named Charles Peck. Now, both Peck and Brown were very knowledgeable about the new electrical industry in the United States, and they were very knowledgeable about how to raise money and publicize new technology. And they knew how to connect new inventions and new machinery to what were ideas and values and wishes that people had at that time. And they taught Tesla how to do that. And that's one of my ideas tonight. One of my major messages is how important it is to not only come up with new technology, but to connect it to the larger dreams and wishes of a culture. Peck and Brown also helped Tesla in a number of ways. They rented laboratory space for him near Wall Street in New York City. The laboratory was located about a block away from what we now today call Ground Zero, or where the World Trade Center sadly was. The building that the Tesla's laboratory was in is long gone. I mean, it disappeared decades ago. Peck and Brown also provided him a salary, and they also offered emotional encouragement. And when Tesla got discouraged and wasn't sure that an invention was going to work, Peck and Brown were like his father, and they would put their arm around Tesla and say, keep going, keep working at it. And they were very, very positive and upright. They were also very smart, and they made sure that Tesla always got strong patents to cover his new inventions. Now, this is where I probably should throw in an equation, since I am at an engineering school, but I didn't. There are some circuit diagrams. Do I have any electronic engineers in the room? Anybody studying electronic engineering out there? No, but they're not going to tell me. Okay. So in 1887, and Tesla had been thinking about an alternating current motor for a number of years before this, but in 1887, with the help of Peck and Brown, he actually gets the thing to work. Now, if you were a typical electrical engineer in this time period, you would have built an electric motor with only 2 wires. Okay, you wanted to save on the expensive parts of an electrical system, which at that point were the copper wires. Okay, so you'd only have, and let me see if I can talk at the same time and point. This is your generator here, and this is your electric motor over here. Okay, so you'd have only 2 wires going from the generator over to the motor. Now Tesla said, but I don't want just 2 wires. I want 4 wires. And the reason why I want 4 wires is I use 4 wires to go between the generator and the motor. I can send 2 separate alternating currents, and 2 separate alternating currents means that I can create a rotating magnetic field. Okay? So you would have like a whirlwind of electricity, or a whirlwind magnetic field in that donut-shaped thing that you see on the left-hand side there. Okay? And anything that you put in the middle of that donut, if it's made of metal, is going to spin around. And the first thing that Tesla put in that donut and made spin around was a shoe polishing tin, just like at least we had when I was a kid. Okay, and the tin can went around. Whee! And Tesla said, cool. Now he showed it to his business backers, Peck and Brown. And they said, let me get this straight. You've worked for a year and you can make a tin can spin? And I'm supposed to like this? So Tesla realized that he was going to have to engage their imagination, the imagination of Peck and Brown, and get them to think about his invention differently. And this brings us to the egg of Columbus, which is the one Spanish connection I actually have in this talk to Tesla. The egg of Columbus is a story that is legendary, and it goes back to Christopher Columbus, and it goes back to talking when Christopher Columbus was talking to Queen Isabella and trying to convince Isabella to support his exploration of the New World, and he needed money. And so Isabella sent in all of the scholars that were in the court to talk to Columbus. And they were giving Columbus a very hard time, as scholars or professors normally do, and they were saying, oh, I don't know, I think the world is probably flat, I don't know, and they're just being difficult, like I do with my students. So Columbus, being I apologize to the translator, but she'll figure out how to say this, being a wise guy, said to the scholars, he said, "Can you make an egg stand on end?" All the scholars said, "Oh, tut, no, we can't possibly make an egg stand on end, no. So Columbus says, "Bring me an egg." And Columbus takes the egg, whacks off the bottom of it, and makes it stand up. Queen Isabella looks at Columbus, looks at the scholars, and she says, "I like your style." And she gives him the money. And off he goes to discover the New World. So this is the story of the egg of Columbus. Now, Tesla goes in one day to see his business backers in New York, Peck and Brown, and he says, "Do you know the story of the egg of Columbus?" And he tells them the whole story, just like I told you. And they say, "Well," and at the end of the story, Tesla says, "Supposing I not only make the egg stand on end, but I make it spin, will you then give me the money to make my electric motor work?" And they say, "Well, we've got a few ducats in our buckskin," meaning their purse, "and we'll do it." So Tesla goes home, and he takes that big coil that I showed you in the previous slide. I can't make the slides go backwards. I can do a lot of things up here. That's one thing I can't do. And he basically takes that big coil, hides it underneath the table, puts a tablecloth on it, goes out, buys a metal egg, calls in Peck and Brown, invites them to watch the egg, turns on the electric power, and the egg spins and comes up on its axis, just like in the demonstration in the exhibit. And Peck and Brown look at him and they go, "We're going to make you a star." And that's what they did. In 1888, Peck and Brown helped Tesla, again, secure good patents. They also helped him give a major lecture at the Electrical Engineering Society, and they made sure that stories turned up in the technical magazines and the newspapers. All of this excitement, this buzz around Tesla's motor, got the attention of George Westinghouse. That's Big George down in the lower picture. And Westinghouse decided that he would buy the Tesla patents for all of that Tesla had gotten for his alternating current motor, and took Tesla to Pittsburgh to go to work for him. Now, Tesla was so grateful to Peck and Brown, and this is often drops out of the other biographies, that he gave Peck and Brown 5/9, more than half of the proceeds that he got from the contract with Westinghouse. In other words, Tesla really understood the importance of his friends and his business backers. Now, again, you get that first job, you try to make a go of it when you go out and work in industry. So there's Tesla, he gets his first job, he's working at Westinghouse, and he doesn't make a go of it. In fact, he doesn't really like working for this big company in this big factory in Pittsburgh. He doesn't like doing the routine engineering, and he quits again. First he quits Edison, now he quits Westinghouse. So where are you going to go? And he leaves the work of developing his motor fully to a couple of very talented engineers, Charles Scott and Benjamin LeMay. Okay. 1889, Tesla, after leaving Pittsburgh and the Westinghouse Company, he goes to the Paris World's Fair, the Paris Exposition that year. And there he meets a graduate student. And notice the interesting way these networks work. He meets a graduate student of the man up there, Heinrich Hertz, and Hertz is just beginning to do experiments where he demonstrates the existence of electromagnetic waves. And throughout the talk, I'll either say electromagnetic waves or EM waves rather than radio waves, because radio waves is a very particular notion of what's going on. But Tesla is experimenting with electromagnetic waves. These are the waves that James Clerk Maxwell predicted with his famous equations. Nobody had seen them before. Hertz was a very talented physicist, and he figured out a way to detect those invisible waves for the first time. Tesla meets the graduate student Hertz at the Paris World's Fair, and he says, "This is really interesting." He goes back to New York, and he says, "But I'm not just going to make the usual Hertz apparatus. I'm going to speed it up. I'm going to make it bigger. I'm going to make it really, really, really cool." And he makes a Tesla coil. And you have a Tesla coil out in the lobby. But basically, Tesla develops that. Now, it is a high-frequency, high-voltage transformer. And what it does is it raises the voltages up into the zone of tens of thousands and eventually millions of volts. And it also raises the frequency up into what we would now call the RF or radio frequency range, or even higher than that. Tesla could take a shock from a Tesla coil like that, largely because he made sure that while the voltage was very, very high, the amperage was very, very low. And that's why he could actually stand there and have lightning, grab the Tesla coil with one hand and have lightning come out the other hand. That is one demonstration I don't plan to do, even for a wonderful audience like this. Okay. Now, you develop this Tesla coil. It's 1891. You can stop and you think, what am I going to do with this? Is there money in this? Where's the opportunity? Now, we would think radio waves, electromagnetic waves, messages, cell phones. Well, Tesla, remember, is not a communications engineer. I'm sorry, he doesn't do telecoms. But he's a power engineer. Okay, he's interested in motors. He's interested in lighting. So he says, maybe there's an opportunity here for wireless lighting. And what he notices is if you take what is similar to a modern fluorescent tube, but in those days they were clear, but it has a small amount of gas inside the tube, and these were called Geissler tubes. And if you take that tube and you place it in the field of the Tesla coil, which you can see the demonstration here, it lights up. So Tesla said, cool, let's make a wireless lighting system for home. And in the other picture you have up there, you see his famous demonstration in 1891, again before an electrical engineering society. And Tesla, this is a demonstration that's done in a dark room. And so Tesla would have had the lights dimmed, and then at the right moment he would have stepped between those two metal plates, which were like 6 or 8 feet square, 2 meters square. And all of a sudden those tubes would have started glowing. And this just fascinated people. How is it that electricity could go through the air, invisibly with no wires, and cause light have light be created? People saw him as a veritable magician. Now, of course, and Tesla thought, well, we can make this lighting system, and we'll just have this metallic wallpaper on the walls of your rooms. And I always thought, probably good idea not to have any children or pets, because you touch or you lick the wallpaper, and, well, that's the end of Fido the dog. Okay. So Tesla, through the middle of the 1890s, continues to develop this idea of wireless lighting. And he does all sorts of demonstrations. This is his New York City laboratory. And in particular, what he would do is he would power up, basically have a gigantic cable around this room, which you can't see, and that would be the primary that you see in the wiring diagram here. That primary there is a big wire that is going around this room like that. The secondary is this little table here, which he could move all around the laboratory, and wherever he wanted, he could have a light go off on top of that table. And again, people were amazed, and he demonstrated that you could not only just do one light, but you could do 3 lights, you could do 4 lights, you could do all sorts of things. And he could demonstrate that he was transmitting power. Again, he didn't think much about messages. He mentioned it, but he didn't really want to do anything with messages. He thought messages, that wasn't the future. As Tesla saw it, the technology that he was dealing in was going through a generation change, much like what we've seen in the information revolution in the last 25 years. But the changes in the electrical technology, each generation came on a scale of a timetable of about every 5 to 7 years. So there was arc lighting, then there was the Edison incandescent lighting, then there was what Tesla did with Westinghouse for alternating current power. And so if you're standing around and it's 1894 or so, Tesla's thinking it's probably about time for the next generation, for the next big thing. And Tesla was figuring that investment would come along and people would go, industry and people would go with his new system of power. So Tesla patented his ideas, and just as he had learned from Peck and Brown, he promoted them through lectures, he did demonstrations, he gave newspaper interviews, and he waited for the businessmen to show up. And no one came. It was like having a birthday party and no one came. And so, the question then is this what happened? Why were there no investors? Okay, well, first off, there was a panic in 1893, which was just like the meltdown of the financial markets we've seen the last few months. They will talk about the panic or the recession of 2008. There was a major panic, and basically industry and the economy in America and around the world from 1893 to about 1898, 1899 was the economy was very poor and no one was investing in anything. Tesla himself created some problems in that he was a wonderful divergent thinker. So you know that I showed you that tube a moment ago that he held up and it lit up because it was near the Tesla coil? Well, Tesla was never satisfied to make just one tube. He had to make dozens of tubes. All different, all, as far as he was concerned, equally wonderful. And this is not something that businessmen or investors want. They want to see the one good design. They don't want to hear about dozens of different ones. They want one good one, okay? And Tesla was never able to really focus, to converge on a single design. Now, why did Tesla tend towards this sort of divergent thinking? Well, there were a number of things going on. One is this is in 1895, through no fault of his own, his laboratory was destroyed by fire. You know, another one is his main backer, really the sort of guy that was his father figure, his guiding force, Charles Peck, died in 1890. And no one ever really replaced Peck as the guiding light in Tesla's life in America. And Tesla had, frankly, some kind of problem with his mental state of mind. I wouldn't say that he was exactly depressed, but there are letters where he basically... Well, there's the first slide is there are days when he's really, really energetic, and as we would say in America, he's up, and he's intense, and he's going to stay up for days on end, and he's going to experiment, and it's going to be really fun, and oh my God, we're going to do everything. So he's really intense. Of course, the flip side of that is there are days when he's really, really down, and there are a fair number of letters that basically say to his friends, well, I'd really like to come see you today, but I don't know whether I can leave my hotel room. And he always, in this time period, rented an apartment or rooms in a hotel. So he clearly had good days and he had bad days, but his mental state clearly got in the way, and probably at crucial times when he needed to finish up a project to show somebody, he just wasn't up to the task. These two men that you see there, finally, Edward Dean Adams and William Rankin did create the Tesla company in the mid-1890s, but that was a speculative venture. Really wasn't going to develop the Tesla wireless technology per se, as much as they were going to get everybody, again, all excited about the technology, sell the stock in the company at a high price, and then leave. And Tesla was never really happy with this strategy, and in fact, he buys these two men out so that he owns the majority share of the company because he didn't want to go down that speculative path. While he's waiting for these investors and trying to figure out what to do, and it's, again, maybe another important lesson here is that when you work on inventions, often the next thing to do is not obvious. When we often kind of simplify the history of it, we often say, well, you know, it's obvious what's the next thing to do. Well, inventors struggle to figure out how to take their technology, how to take the creative work that they're doing in the workshop or the laboratory and decide where the next good commercial application is. So along the way, Tesla experimented with X-rays, which were discovered in late 1896 and were all the rage in 1897. And he also developed a boat which could be controlled by radio waves. Not quite remote control, but the boat could actually start and stop by getting an on-off signal from on shore. And that's a model that they have in the museum in Belgrade, the lower colored picture. In the meantime, Tesla was thinking about how his system worked. Now, Tesla got really hung up on the idea that, like light, well, electromagnetic waves are one form of light. Okay, radio waves and light are just in different parts of the spectrum. Okay, the light waves, obviously, most of those, except for infrared and ultraviolet, we can see with our eyes, and the radio waves are invisible, but they're all the same phenomenon. So Tesla got hung up and he thought, okay, if electromagnetic waves, the invisible waves, are just like light waves, that means that they travel in straight lines. And if they travel in straight lines, that means that if you build a big transmitter and you are generating lots of electromagnetic waves, Guess what? They're just going to keep going into space. And like the Energizer Bunny, do you have the Energizer Bunny here for Duracell? They just keep going and going and going, okay? So bad idea. Most of your energy, if you think that the radio waves are being radiated out into space, 95% of the energy is wasted. Now, of course, what we know today, and what Tesla didn't know, is this radio waves and television work because the radio waves bounce off the ionosphere. In other words, they stay inside basically inside the Earth's atmosphere. Okay, but Tesla didn't know that. He thought, well, they keep going. That's a waste of time, so I'm going to do something entirely different. He said, instead of maximizing the radio waves, which is what Marconi and other experimenters did at the time, he said, I'm going to minimize the radio waves coming off of my antenna, and I'm going to maximize the ground current. Okay. So this is one of the great scientific lessons of the evening. I know that you were hoping for, more rock stars or something, but you got to get a little more science in here. Okay. Now, the top is the typical situation. Okay, and in that case, I'm going to turn this around so that these folks can see, because then I know what I'm doing. I should know what I'm doing here. Okay. So you got a transmitter, you got a receiver. Okay, in the world of radio today, or Marconi, the transmitter sends radio waves to the receiver, okay, and it's picked up by the antenna over there to the receiver, and then to complete the circuit, okay, there is a ground current that is generated down here, and it goes back, and it is picked up by the transmitter, okay, so the path is in this direction. Now, Tesla said, no, completely different. He said, what I think is happening is you generate from the transmitter a ground current, send your energy through the crust of the Earth, and then to complete the circuit, you have radio waves, or you have something going through the atmosphere. Tesla actually thought it was probably not radiation, i.e. waves, but an oscillating current. So Tesla, having decided this, whoops, sorry. Okay, decided that the thing to do was to make this work was to basically build a transmitter and receiver. Like you can see here, there's his transmitter, there's his receiver, there are the light bulbs that are going to light up, there are little motors that he's going to have. Okay, and again, his idea is this is from this plate in the ground to this plate in the ground, the electric energy runs. Okay, now to get a good return on the other end, he said these things up here, these marked D and D prime, are going to be balloons. Cool. Okay. The only problem is initially Tesla figured that the balloons, they might have to be a mile or so up. Think about the wire and the weight of the wire that you're going to have going from this tower in New York City all the way up to that balloon. That balloon would have to carry a lot of weight. Okay. But for Tesla, he said, details. Somebody else will figure that out. Don't worry about that. So while Tesla is figuring all of this out and raising some money from John Jacob Astor IV, who is, if you've seen the movie Titanic, he's the guy who basically says, women and children into the lifeboats first, and John Jacob Astor goes down with the ship. Okay, so, but this is years before that. This is 10, 12 years before that. So Tesla's raising money from Astor. Things are looking up, very promising. And he finds out in March of 1899 that this young Italian student at the University of Bologna has, bit by bit, improved a wireless telegraph system. That was really what Marconi was working on, wireless telegraph. He said, let's make something that works just like the wired telegraph that you have on land. Let's make it wireless. Okay, and Marconi successfully sends a message across the English Channel, which gets a lot of publicity and a lot of excitement. Worried that Marconi is getting ahead, Tesla said, I've got to do something. I've got to really get things figured out about my system. And he goes and he spends about a year in Colorado Springs. And one of the things I got to do this summer is I got to stand at the site where Tesla's laboratory was in Colorado Springs. I'm sorry to say that it is a typical American suburb, and it's basically an intersection of two streets, and there are just 4 ordinary houses surrounding it. I suspect the houses have really interesting magnetic fields as a result of doing stuff like you see in the left-hand picture, but I couldn't tell you. Anyhow, so Tesla builds for himself the largest Tesla coil possible, okay? And it is essentially a 60-meter or 60 feet circle, and that is the primary of it. That wall back there, there's a big cable running across the top of it that you can't see, and this is the secondary, okay? And when you pump electricity into this thing, it steps it up, and it steps it up so high that you can get your own artificial lightning. Tesla claimed that he got bolts upwards of 135 feet across. Okay? Now, that is Tesla sitting there in this picture, but before you think he's a really brave guy, I need to tell you how he did this picture. Basically, this was a double exposure. Okay, so first, and it was done on with a great big old-fashioned camera. So first, Tesla poses with none of the current going through the system. He poses. They take the picture with him sitting there. Okay, then he gets out of the way, and they crank up the machine, and they make the bolts go flying through. Okay, still a pretty cool picture, but that's how he did it. Okay, now what Tesla's thought is when this machine, this transmitter is working, he could get electric lights all over the world to light up. So this is one example of one of the few pictures that he has that shows this in Colorado Springs. This is a great big coil up here that you can't see, but underneath the coil, tucked away, is a little tiny light bulb, and it's glowing because it's getting power that is moving through the earth from this transmitter through the earth to that light bulb, and this coil is basically the receiver. Okay, note there is no antenna. That's just this sort of end of the wire hanging up there at the top. Tesla was convinced that he had sent power when he was in Colorado Springs around the world. He had basically bounced power through the core of the earth to the opposite side of the world from Colorado Springs, and it had come zipping back. And he was convinced he had done it. Okay, and so he went back to New York, and he announced that he was going to scoop Marconi. Marconi, yeah, I say to Marconi. And he announces in the papers, don't worry, boys and girls, I will send a message in 8 months across the Atlantic. And to promote his ideas, and Tesla now was really pretty confident, a lot of ego, a lot of, as we would say again in America, full of himself. So he writes a 60-page treatise for a popular magazine on the problem of increasing human energy. And he talks about everything. Everything. He says this is how diet has got to change, this is how behavior's got to change. By the way, you should be a vegetarian. The future of the world belongs to aluminum. It goes on and on and on. Some people think that this is like the secrets of the universe in this article, and I've read it now probably about 10 times, and if there are secrets to the universe in this article, I haven't found them yet. It's interesting in that it is so, Tesla has this vision that he's going to fix everything in the world. Very different than his rivals at that point, like Edison. Edison would never write a 60-page article. Tesla also decides that he's going to need the next big thing, and he moves into the Waldorf Astoria and is living the good life. In 1901, the article does the job that it does. It engages people's wishes and dreams. And J.P. Morgan, the famous investment banker, this is the J.P. Morgan that we've been hearing a lot about in terms of Morgan Stanley, they basically put up the venture capital of $150,000. And Tesla goes to Long Island on the North Shore, and he builds for himself this transmitting station, which is, the transmitting station is in the big brick building, and then he builds for himself a 175-foot tower here. Now, the interesting thing is you said, well, what about sending the power through the earth? Well, the tower is nice, but the key thing is he also dug a tunnel, a well, 200 feet into the earth. Okay, that's where the power is going to go. Okay, now, he started working that in 1901, doesn't quite finish it until 1902, 1903 by the time you see those pictures. So what happens in the fall of 1901? Well, that pesky Marconi guy is back. Worried that Tesla is going to beat him, Marconi says, I can't wait any longer. Even though my antennas, my great big systems of wires that I've set up in Cornwall, England, that's where Poldhu is, and Cape Cod in Massachusetts have fallen down in storms, I have got to get a message across the Atlantic and beat Tesla. And so in the fall of 1901, just about probably the last chance he has in November of that year, Marconi goes across the Atlantic, goes to St. John's, Newfoundland, and there succeeds in detecting a message which was basically 3 dots. Now, to this day, there are people within the history of telecommunications or radio communications that would sort of say, all we have is Marconi's word that he actually did it in 1901. Okay? But Marconi, as time went on in 1902 and 1903, always came up with another demonstration that naval officers could see, that newspaper reporters could see, and bit by bit demonstrated that he had clearly succeeded in sending a message across the oceans. So what is Tesla's response when you've been scooped? Well, Tesla says, I'll tell you what. You've been scooped like this, you really got to come up with something pretty interesting to get people's interest and attention back. So he announces that while he was at Colorado Springs, he had detected radio messages or wireless signals from the Martians. Okay? Now, needless to say, that's pretty cool, but it pushes you on the wrong side of whether you're a genius or you're a nutcase. Well, that's such a smart thing to do. Okay? Tesla continues to work at Wardenclyffe, but he soon uses up Morgan's money and is unable to raise any additional money. Now, one of the interesting things is you sort of say, so Marconi is doing all this stuff and is getting a lot of attention, and wireless looks like the next most promising technology. So, why don't people set up a Tesla radio or wireless company and invest money? Why is Morgan ignore Tesla? And part of it is in this period you have the early 20th century equivalent of what we call in the United States in Silicon Valley vaporware. In other words, software that is promised and is going to be wonderful and is going to change the world. And what happens to the stock price of Microsoft Word as they keep promising a new release and the new release doesn't come? The price goes up and up and up. Okay, so you basically have people that are speculating on the promise of radio, set up radio companies that are complete frauds. And J.P. Morgan basically tells Tesla, he says, look, I don't really have a problem. You're kind of an unusual guy, but I don't have a problem with this. The problem I have is I can't get associated with all of this fraudulent activity around radio companies. In other words, I can't touch it, and this was Morgan's words, with a 10-foot pole. And so as a result, Tesla couldn't raise any more money. Now, there is a bigger problem that Tesla also faces, which is you're going to pump lots of electricity into the earth. So how does the earth function? Does it function like an ocean or like a water balloon? Okay, now, Tesla thought that the earth, when it came to electricity or electromagnetic waves, functioned like a water balloon. So imagine you got that. Did you make water balloons when you were kids and throw them at each other? Or you're all well behaved in Spain? Did you have what? They had water balloons. Okay, so, but remember how you squeeze the water balloon, and if you squeeze it on one side, the water all rushes to the other side? Okay, so imagine you have the analogy side picture here. I'll turn this so that my hosts up here can see. The left-hand side, imagine you got a whole series of little tiny valves all around the ball. Okay, those are the receivers all around the world. Okay, and you got a pump, and you pump on one side of the water balloon. So what happens at each of those little valves or spigots all around the balloon? You get the right frequency, the right rhythm of pumping, and the water comes spurting out of all those little holes. Cool. Okay? And that's what Tesla thought would happen. You pump in enough energy into the earth, you come to the resonant frequency of the earth, okay? And once you did that, all you have to do is put a few percentage of additional electricity in, and the electricity would come popping out on receiving stations all over the world. Okay? Now, the only problem is the world doesn't work like that. Okay? The world is like an ocean. So you basically drop a stone on the shore as we would always say, the nearest place to where I grew up in New Jersey was Cadiz. The city Cadiz. Okay. Cadiz, Spain, was the nearest place where I grew up in New Jersey. And so we'd always say, next stop was Spain. Okay, so if you drop a rock on the ocean on the New Jersey side, the waves from that rock do not travel all the way to Spain. Okay, eventually they peter out, they disappear. Okay, and the same thing would have happened when Tesla pumped electromagnetic waves into his station at Wardenclyffe on Long Island. Eventually, the radio waves, they might get to Boston, they might get to Montreal, but eventually they'd peter out, they'd disappear. Okay, so sadly, the water, I hate to break it to you, but the Earth does not work like a water balloon. You heard it from me first. Okay. Now, a couple of points, again, because there's lots of people. Notice that I've never said that Tesla invented radio, okay? Okay, radio means a whole number of things, but most of the time, radio means a system of broadcasting messages or communications. Tesla did not want to go down the communications path. He was very creative about using electromagnetic waves to do other things, but he didn't invent radio. He was the master of doing experiments or building new technology about electromagnetic waves. That's very clear. But Tesla didn't succeed with wireless power for several things. He didn't have enough money, and unlike Marconi, who kept having very careful demonstrations that showed that the thing was getting better and better and people would invest more and more money, Tesla went for it was all or nothing with Tesla in terms of demonstrating it. He had no clear business model. So how was he going to make money from this? Was he going to sell equipment? Was he going to provide a service? Was he going to have a monopoly? And again, these are not obvious answers. And all of the early wireless inventors, Marconi and the others, had real problems trying to figure out how you were going to make radio into a successful business. And again, Tesla had the practical problem that it's not clear how power or currents would not transmit through the earth. In the end of his life, Tesla, frustrated about what was happening, and this is sort of the sad part of the end of my story, but frustrated that he could not raise the money and make his dream come true out at Wardenclyffe, Tesla has a nervous breakdown 1904 and 1905, okay? And he never really recovers from that nervous breakdown. He has a long period of depression through the 1900s. He goes on to work on several other inventions, primarily because he hoped to raise the money in order to finish his wireless power scheme at Wardenclyffe, but he never raises enough money. He lives in a number of hotels. He becomes more and more of a recluse. His best friend is a pigeon, but you can ask me about that in the question and answer period. And sadly, in 1943, Tesla passes away. So I promised that, again, as a historian, as a biographer, I'm interested in the ups and downs of his career. He goes from rags to riches to frustration. So what are his strengths? What are his weaknesses? One of the things to take away is Tesla tended to think like a maverick. Okay, he didn't think like all of the other typical engineers or business people at his time period. And in fact, he would often go in the opposite direction. Everybody was going to send radio waves up into the air. Tesla said, no, well, I'm going to concentrate on sending that current through the earth. Everyone is going to use 2 wires for their electric motor. I'll use 4. Okay? That was one of his great strengths. His other great strength was his willingness to connect his inventions to cultural values. He was great at getting people to imagine all of the wonderful things that were going to happen with this new electrical technology that came along. And one of the examples that I can use at this point is Tesla, when he's talking about his wireless scheme, he said, I can actually figure out how I can send thousands of individual messages to little devices that people are going to carry in their pockets. And so, yes, he did predict, he did dream, was nowhere near perfecting it, but he did dream of the possibility of having something that looks like the modern cell phone. But he was there because he was thinking about how his technology got connected to the wishes and needs of people. His weaknesses were, this is clearly, he struggled with his emotional state. He had good days, as I've said. He had bad days. He probably suffered from some kind of depression. And his other weaknesses is he often made some unusual assumptions about how markets, how the business place was going to work, and how the natural world worked. He did think, again, that the Earth was a giant water balloon. Now, I should hasten to say, water balloon is my term, not his. He often talked about a football and how you would pump up the football. But Tesla really has, I want you to leave you with two thoughts about his legacy, okay? And the first is this is a picture of, it's often shown to show light pollution in terms of astronomers. But as a historian of technology, as somebody who believes in progress, what I think is important there is to realize that all of that lighting is a result of electric power systems that are operating around the world. And it is a result, most of that power is transmitted using alternating current, and even more specifically, using multi-phase, 2 or 3 phase alternating current. And Tesla is the individual that is responsible for introducing the idea of using multi-phase alternating current. Without Tesla, it would have we might not have even ever gotten to the point where we use multi-phase. Okay, so from a technical standpoint, this picture sums up what he really accomplished. But I want to leave you also to thinking about Tesla, as a person. And he reminds us of a number of important virtues, of important characteristics that we as engineers, as managers, as creative people, should be thinking about in a technical school such as or an engineering school such as your own, or the engineering school where I teach. And I always want my students to think about these sorts of things. Tesla shows us the importance of dreaming big. He wasn't going to make a little motor. He wasn't going to make a little electromagnetic or a little radio system, a little wireless power system. He was going to power the entire world. This is a man who dreamed big. And it's good to have people in our society who dream big. He was willing to take chances. Whether that chance was coming to America, that chance was throwing in his lot with his business backers, Peck and Brown, whether it was taking chances in building as big a system as he did at the end of his life. And he also reminds us again and again of the importance that technology succeeds not just because of technical reasons, but when inventors are willing to connect their technical ideas, their technical systems, with human wishes and cultural values. And just to wrap up, you probably know that Tesla lives on in the popular imagination. On the left-hand side is the new Tesla Roadster, which is an all-electric vehicle, can go from 0 to 60, 3.9 seconds. I've forgotten how much it actually costs. They are finally rolling off the production line this year. And on the right, if you haven't seen it, you should check out David Bowie playing Tesla in the Hollywood movie, The Prestige. Thank you, and I'll be glad to take some questions.
Now it's time for questions. Hello, thank you. Please, just a moment. Please, please keep quiet. What a moment. I know it has been a very amazing speech, a very amazing conference. I want to thank you very much to Professor Carlson for his conference. It has been very, very interesting, and now it's time for questions. You can address these questions to our speaker, both either in English or Spanish, as you prefer. I can translate or I can...
¿Está preparado?
Is there any... ¿Hay algún casco?
Sí.
¿Se la hago en español o en inglés?
Si quieres hablar en inglés, puedes hacerlo en inglés.
Bueno, primero lo hago en español.
Oh. Yeah. Oh, I'll get
La gente, ¿no? Sí, primero, gracias. Thank you so much to ¿cuál es su nombre? Bernard for the lecture. Y bueno, quería preguntarle acerca de unas grandes controversias que está habiendo por internet. There are a lot of discussion in the internet about the secret researches of Tesla. Por ejemplo, la influencia que la investigación en la energía electromagnética ha tenido, bueno, pues en lo que ahora se conoce como energía libre, que hay de cierto en una conversación que tuvo con JP Morgan, en la cual supuestamente a Tesla se le escapó decir que con sus inventos la energía sería gratuita. Y... ¿me está oyendo? Ahora se lo repito. Bueno, se lo voy a volver a repetir porque el tío no se está enterando de nada.
Preparándolo.
Right.
Sí, le estaba contando un poco que bueno, aparte de lo que ha contado, que es muy interesante, pues hay mucha controversia en Internet acerca de, bueno, de la parte oscura de Tesla y la parte que nos han ocultado. Se ha hablado mucho de Edison, pero se ha dejado a Tesla en el olvido. Y ahora hay un gran movimiento en Internet que está intentando sacar energía de los imanes, de la energía electromagnética. Entonces se dice que Tesla desarrolló esta energía y que JP Morgan, como bien ha dicho, pues Tesla no era muy bueno con el dinero y por lo visto se le escapó un día cuando estaba tomándose unos vinos con el banquero que con sus inventos la energía sería gratuita, y fue en ese momento en el cual JP Morgan le dijo que bueno, hasta aquí hemos llegado. Y luego la otra parte es, bueno, a ver qué hay de cierto en que las investigaciones de Tesla sobre ondas electromagnéticas son el origen del proyecto HAARP, H-A-A-R-P, High Advanced Aurora Research Program, que supuestamente es capaz de manipular el clima a través de antenas. Y también sería el origen del escudo antimisiles.
Right.
El escudo antimisiles este.
Okay. So, okay, I Okay, so thank you for your interesting comments and questions, and it is, for me, it's very gratifying that Tesla has such a strong following on the internet, and that there is a great deal of interest in his work and his contributions today. It means it's far more stimulating because there are people that are debating what's going on, whereas a lonely historian in an archives often says nobody's really interested in this. Now, with regard to J.P. Morgan and the question that Morgan got out of working on wireless because the Tesla planned to transmit it for free. As a historian, let me remind you that what I do for a living is as I go to museums and archives and libraries and I look for the materials that are the closest to the person that I'm studying. So I have been to Belgrade to work with the materials at the Tesla Museum there. I've looked at testimony from various patent court cases in the United States. I've been to the J.P. Morgan archives. I've studied this fairly carefully. And my sense is that in the period 1902 to 1907, when Morgan would have had to make a decision whether to keep putting money into Tesla's inventions or not, there are two things going on with Morgan. One is there is this whole problem that no one is making money off of radio, whatever their business model is, whether they're going to give away the power for free or they're going to charge for messages or whatever they're going to do. And so Morgan looks and says, this is an underdeveloped, unripe technology. I'm not sure I'm going to put any more money in it. The other problem, which has been lost, is this issue about the fact that it was a highly speculative, fraudulent business in the way that people were investing in radio in this period from 1902 and 1907. And the Marconi Company had problems with this. Lita Forrest had major problems with this. And so I would argue that no, it has to do with very basic business decisions that is going on with Morgan. I've also never heard or seen anything in the Tesla correspondence or in the Morgan correspondence that suggests that they had this glass of wine and that this conversation took place. That is just the way it is. Now, you've raised another interesting question, which is the whole issue about HAARP and also what's known in the United States as the extra low frequency or ELF system. And for a number of years in the 1980s and so avoid a little electromagnetic resonance there. Okay. Beginning in late 1970s through to the 1990s, the United States Navy experimented extensively with extra low frequency. They did succeed in doing what Tesla proposed, which was to send radio waves at a much lower frequency than Tesla anticipated through the surface of the Earth. Okay, and also basically these waves propagated between the ionosphere and somewhere into the Earth's crust. And as a result, the radio waves penetrated the ocean, which was a good thing, because during the Cold War, you had to be in constant contact with your nuclear subs. And in fact, the ELF sent what was known in Navy parlance as the happy signal. And it was a continuous signal that the American submarines got, and as long as they got the happy signal, everything was all right. The Soviets had not dropped a bomb on New York City or anything, but if the happy signal ever went off, that was when they went to station and they got ready to launch the missiles. Okay, so the HAARP was used primarily for a signaling system for work with the submarines. Whether or not it has, as you quite rightly asked, environmental impact is something that has been actively debated, but my understanding is now is the United States Navy has moved on to entirely different telecommunication systems and doesn't use the extra low frequencies any longer. But that's a long answer to two very interesting questions. So, please.
More questions?
Somebody wants to know about the death ray.
¿Ya está? Bueno, he oído su exposición y hay algunos problemas. Hay algunas cosas que me han quedado un poco oscuras. Una de ellas es que si me digo usted si es verdad o mentira que la Corte Suprema de Estados Unidos, a la muerte de Tesla, le considera el auténtico inventor de la radio, ya que 17 patentes que había sacado él, descubierto él, fueron aprovechadas por Marconi para crear la radio. Luego, usted tampoco nos ha hablado de la creación por Tesla del motor de inducción. No nos ha hablado usted tampoco, por ejemplo, de que la primera central eléctrica generadora de corriente la creó Tesla en el Niágara. O sea, la sensación que me ha dado un poco en su exposición, que ha sido muy amena y muy simpática, es que este hombre era poco menos que un visionario, un hombre que prácticamente no hacía nada. O sea, que solamente se divertía haciendo cosas que posteriormente los industriales le decían que no valía para nada porque no era posible convertirlo en dinero. También le quería recordar que a la muerte de Tesla, en el año 1943, todos sus documentos de la segunda época de su vida fueron requisados por el gobierno de Estados Unidos y todavía hoy están clasificados, es decir, no están de uso público. Le quería preguntar a usted también, que ya que es un historiador, pero me imagino que también ha estudiado este tema. Otra pregunta, la segunda pregunta es, ¿realmente se sabe algo de estos documentos? ¿Se han desclasificado ya en algún momento o no?
Thank you for your questions, and let me make sure that I answer each of them. I could have quite reasonably included a slide and talked about Niagara Falls and Niagara Power, but in the interest of time, I wanted to tell a more complete story about the wireless power, and so I had to set something aside. But Tesla indeed is the person, as I emphasized at the very end, who convinced Edward Dean Adams, one of Tesla's business backers, to go on ahead with Niagara, and in particular to use alternating current and, in the case of Niagara, two-phase power as a result of that. And one of the important points is Tesla is very deeply involved in convincing businessmen that the alternating current motor or alternating current power transmission should be done at Niagara. Okay? I do not see Tesla as being a mere visionary. I see him as someone who struggled extremely hard to succeed in bringing his technologies to commercial use. He hit a grand slam home run, as we would say in American baseball, with the alternating current motor. There are very few inventions in either the 19th or 20th century that were as significant as the alternating current motor. As one of my professors used to tell me in his undergraduate lectures, is go home and count up how many alternating current motors are in your home, and then thank Tesla. Okay? So he's not a visionary. Now, in 1945, the United States Supreme Court handed down a decision in which they wanted to break up the monopoly that the Radio Corporation of America, RCA, had in the area of radio telecommunications. The way that they did it was they showed that there was prior art in the area of radio ahead of Marconi, because RCA in America was basically an outgrowth of the Marconi company. So to show that RCA had no credibility, they went back and they looked and they said, some of the circuits that Marconi used are also duplicated and actually are in earlier patents done by Tesla. Now, that is what the United States Supreme Court was specifically doing in that particular case, was breaking the RCA radio monopoly. Does that mean that Tesla invented radio? Does that mean that the United States Supreme Court decided that Tesla invented radio? No, they solved a very particular monopoly or issue about who should have the monopoly in that particular area. The question of who invented radio, it depends on what you mean by radio. If you mean simply the transistor radio or the radio that you have by your bed or in your kitchen or what have you, then that's not even Marconi's invention. That's the invention of Sarnoff. It involves circuitry that was developed by a whole range of people in the 1910s and 1920s. Okay, but if you mean by radio the first person that actually creatively used electromagnetic waves to do something useful or interesting, then we can talk, because Tesla was the first person to see potential in those invisible electromagnetic waves. But that doesn't mean that he invented radio in any narrow sense of the word. Now, the papers that you've asked about, in 1943, Tesla dies, and his heir is a man named Sava. I've forgotten now. I apologize. But his heir is Sava Jovanovic, and is the ambassador for the Yugoslav government in exile to the United States. And it turns out that the problem is that Jovanovic was not a U.S. citizen. So as a result, the U.S. government, particularly under J. Edgar Hoover and the FBI, says, we do want to have a look at these papers, because for the previous 5 to 7 years, Tesla has been promising that he had invented an invisible ray that could shoot down airplanes. And if it was true, in the middle of World War II, the United States, the Allies, were going to check it out. Okay? So they collected the papers. They went to an Army Air Force base, what's now called Wright-Patterson Air Force Base out in Ohio. They were examined. And the United States government decided in about 1951 to give the papers back to the rightful heir of the papers, which was the nephew, who at that point had returned to what was then Yugoslavia, and he in turn arranged for the papers to be deposited in a museum in Belgrade, what is now modern-day Serbia. And all of the papers are today there, 150,000 pages. I've seen some of the materials there, but they are still generally not readily available to the public. But I think it has more to do with the cultural legacy that the Yugoslavs and then the Serbians feel towards Tesla, not because there's some deep, dark secret that's waiting to be found out. So.
¿Preguntas?
Gracias. Quería preguntarle sobre el precio que se pagó por las patentes de Tesla cuando él llegó a Estados Unidos. Hay mucha controversia. Algunas personas dicen que un precio fijo, mayor, menor. Incluso hay gente que dice que se pagó, vamos, que fue el precio que Tesla pidió fue de $2,50 por cada caballo de vapor que se generase con sus inventos. ¿Hay algo de cierto en ello? Además de eso, si me permite hacerle una pregunta más, uno de las patentes un poco más olvidadas de Tesla es la turbina de Tesla, la bladeless turbine, turbina sin cuchillas. Me pregunto por qué esa turbina ha quedado tan olvidada cuando él decía que tenía una eficiencia altísima, que hoy en día casi no lo consigue nada. Y si puede explicar el fundamento del death ray, del rayo de la muerte, se lo agradezco. Muchas gracias.
So the first question concerned what royalties did Tesla receive from the Westinghouse company when he signed over the motor patents in 1888. Okay, at that point he received, which he again shared with his backers, a portion of, or 4/9 of $150,000 cash. There was also another payment of, I believe, $50,000 that came in 2 years later. He again shared a portion of that. And then he did receive $2.50 for every horsepower of the electric motors that were installed. Altogether, by the time that altogether as a result of this, I calculated that Tesla probably netted about $200,000 from the entire package deal. One of the reasons why he didn't receive more money is this because, as I mentioned in passing, they did not build a lot of Tesla motors between 1890 and about 1893 because there were a number of technical problems in working out how to make this motor work well on the existing alternating power networks at that particular time. And in fact, Westinghouse got into a problem with financing his company in 1892, and went to Tesla and asked Tesla if Tesla would tear up his contract because basically Westinghouse could not refinance the company with this debt hanging over the company's head, which could potentially grow to be really, really big. Tesla said, "I will help you out because you've invested in me, you've taken a chance on me," and he tore up the contract. And as a result, Tesla really did walk away over the long haul from millions of dollars. Now, you asked about the bladeless turbine. Tesla began working on the bladeless turbine in 1904 and 1905. And again, Tesla had an idea that rather than having a turbine in which, like a jet engine, the steam comes parallel to the axis, the axis or the rotor of the engine, Tesla said, introduce the steam, and because steam has a very particular set of viscous characteristics, if you make the space between the blades sufficiently small, the steam will kind of get stuck in those blades and the whole thing will turn. Okay, but the steam is introduced at a 90-degree angle to the shaft that is going to be operating. It was a wonderful idea. There are still companies in the United States that are working on it. The difficulty is, as I understand it, is on an engineering standpoint, which is for it to work, this whole turbine is going to turn like all turbines at incredibly high speeds. We're talking, thousands of RPM. Okay. The problem is you have to make the blades incredibly thin, and at the same time able to take the forces that allow it to spin incredibly fast. And they have not been able to come up with the right metals to do that.
Por favor, guardar silencio, por favor, si sois tan amables, y os prometo que después de esta pregunta nos vamos, así que os ruego que os mantengáis en vuestros sitios y no perturbéis el desarrollo de las preguntas. Gracias.
Nothing I have to worry about. Okay. Okay. The final question is the death ray. Okay. So Tesla had an idea at one of his birthday interviews in the 1930s that it should be possible to basically create, using high energy electric waves, a stream of charged electric particles that would be able to travel across the sky and bring down an airplane. Okay. Now, this actually was an idea that was kicked around by a number of air forces in the 1920s, and in particular, the Royal Air Force in Britain experimented with this extensively and worked with a particular physicist there, and they were able to actually successfully do this. Now, the way that it actually worked is it didn't damage the airplane. What it did is it was basically a stream at about the frequency of microwaves, and what you did is you basically raised the temperature of the blood in the pilot until the blood literally was too high, and the pilot died. Basically, you didn't quite make his blood boil, but you got the blood. If you could get the 4 or 5 pints of blood in a pilot up to about 110 degrees Fahrenheit, then he would die. And that was the whole idea with the death ray.
Última pregunta. Sí.
Por Dios, Carlson, muchas gracias por su intervención. Creo que ha sido muy interesante. Hay una cuestión que yo quisiera incidir a estos jóvenes futuros ingenieros, que el concepto de alternador, de corriente alterna, les invito a que profundicen. Pero ahora la pregunta es la siguiente. Yo viví el caso en su momento del doctor Brown, cuando tuvo que ir de Estados Unidos a Alemania a estudiar matemáticas, volver a formarse matemáticamente cuando la carrera espacial tomó el vigor que tomó. A los ingenieros se nos critica, no sin fundamento, que somos un poquito ligeros a la hora de la aplicación matemática. Yo desconozco si el físico ingeniero Tesla tuvo alguna formación matemática especial o se recicló, porque no veo en su biografía, que realmente no la he estudiado, si los planteamientos físicos y eléctricos, en definitiva, electromagnéticos, tenían basamento matemático sin el cual es imposible progresar. Sirva esto también de invitación a estos futuros ingenieros para que no desprecien esa componente, ¿no? Pero la pregunta es esta: ¿tuvo alguna formación matemática especial a la cual no he visto nunca referencia?
So the question is how much mathematics did Tesla use in his creative work? And the answer is Tesla did receive a fair amount of mathematics, at least some calculus, when he was educated at Graz. And throughout his career, he uses mathematics to make a series of calculations in terms of sizing the various components that are going to be in his motors, in his generators, and then ultimately in his electrical circuits. I think he was a pioneer, and one of the interesting things is when he was working on the early wireless power system, he's developing some of the first electronic circuits that have resistors and capacitors and inductances, and he does have a pretty good sense of how those things can be represented mathematically, and tries to calculate rules of thumb to guide how he will build future circuits. And as he says, his work when he was in Colorado Springs was much like a naval architect who builds a small model of the ship, tests that, and then builds the larger ship on the basis of that. So he had the mathematics that allowed him to scale it up. He was not part of the ultimate efforts to create a mathematical basis for electrical engineering as we know it today. That was done by people like the Serbian-American Michael Pupin or the German-American Charles Steinmetz, who realized that if you were going to invest millions of dollars in large-scale electric power systems, then you needed to be able to predict the behavior of those systems pretty well before you started building them. And that was something that was happening at the same time as Tesla, but he was not part of that larger professional project. But he did use mathematics throughout his notes and throughout his work.
Okay. Thank you very much. Gracias, Bernie.